A correction, hallucination is not a problem. Hallucination is the feature. So, hard hitting statement to start with. We are trying to get rid of hallucination. Let's understand that hallucination per se in large language model is not a problem. And when I say this, I'm actually presenting a paper that I had written. The crux of the paper is always, it's not LLMs hallucinate. The crux of the paper is LLMs will always hallucinate. And next thing is, rather than making it gloomy, at times it will hallucinate that are right, you know. So the basis of generation in large language model is hallucination. So I have one, poem on the first slide where the mind is without fear and the head is held high. Tagore, when he wrote it, India was colonized. There was absolutely no hope of everything. So technically speaking, this poem even today feels like a hallucination, and Tagore could write this creatively because possibly he hallucinated. So the creativity per se is hallucination. It is not repeating the reality, right? So if we do not hallucinate, like if the systems don't hallucinate, they become repetitive, boring, and that's where I am starting my context. In case you are interested, this particular paper actually went viral. Like, normally papers don't go viral. I had put this paper in archive. In 3 days, I had like 2 million views on the paper. I mean, I don't know who reads academic papers. It's slight mathematical, so most of the proofs that I have used here are core mathematical into the core mathematical foundation, and I'm going to talk about all of it. In case you have downloaded, I don't want to talk about me, it's like boring again. Now, hallucination, let us understand there are few ways which are, hallucinations that we are having problems with. So while I said that it is the feature of language model to hallucinate, it is not the bug of the language model. But there are few cases hallucination can make massive problems for us. So let's address the problem statement first. It can throw up things which are factually incorrect. It can fabricate things that are not there. Third one is extremely important, needle in haystack problem. Like you have so many things to be found, and you just can't find the right thing from the set of lot of variables. And next one is misinterpretation, which is you ask for something and it delivers you completely something different. So as I said, hallucinations are features, not bugs. So there are two different type of hallucination that we found, and I will talk about the structural hallucination. This is what was invented by us, our team, that structurally the machines will hallucinate always. No matter how much you train, the structural hallucination will never go. So that is the structural hallucination I'll talk. Algorithmic hallucination, yes, we are working on that. Still, we need to understand structural hallucination so that we can mitigate it. My point is that it will not hallucinate, or it will hallucinate. My point is, given the fact that we cannot live without hallucination, how best can we mitigate that hallucination is my limited point out here. Algorithmic hallucination is something that is a limitation of the existing set of algorithm. It can be your order of computational complexity, or lack of data. And I'm going to give you an example wherein at times more data can lead to more hallucination. And I have that example for you as well. So it's not always about lesser data means more hallucination. So all those algorithmic part of hallucination is still there. But I will cover, or this particular talk will be more focused around the structural hallucination part of it. Now, there are few claims. Training, intent classification, information retrieval, output generation, and post-generation facts checking. These all are, traditional mitigation strategies. I don't want to go deep because of the time constraint. I want to keep a lot of time for us to actually engage and discuss about things that we are going to talk. Next one. Now, this is where things get complicated. Training. You cannot have a data set which is complete. So a training can never be complete. So first thing about hallucination is you cannot have a complete data set to train. You can say, okay, it can train everything, but yesterday I came to Bangalore, almost I was about to lose my flight. At least that data I know the traditional LLMs don't have with them. So a complete fact of the world is an utopia. And mathematically it can be proven that there cannot be a data set that can contain all the facts. Okay, I'll not go to the mathematics, let's do it logically. I'm just making up a fact and follow my sentence. It is a fact that there are facts beyond this fact database. If this is a fact, then it says that the database does not have all the facts. But if it is not a fact, means my fact database has something which is factually incorrect. So there are contradictory statements, and with those contradictions, we have to prove always, we always take those contradictions, right? So if mathematically we can prove that this can well be a fact, right? Suppose this is a fact, which is a part of my training data set, then this fact in itself tells them that my training data set is incomplete. I can never make it complete. That's the first thing. Second, intent classification, which is what I say, and we as human beings also, we do a lot of wrong classification. We talk, we misunderstand. The whole purview of misunderstanding in the human society is because we do not classify intent properly. We say something and we don't understand whether the other person who is sitting in front of us understood the same way we said this. So that is the problem with intent classification. So in intent classification, we have 2 world records. In SNLI dataset, so you can just check paper with code, the top 2 ranks algorithms are by us, not by the biggies like Google's and Meta's. My record in intent classification, I'm talking about specific SNLI, Stanford Natural Language Inference dataset. The record that I hold is 94.7% accuracy. That essentially means the data, the understanding over what user is saying is at least wrong to about 5.56%. Even we human beings, we make it wrong. Like we come out with an intent, say something, and the other person understands it completely wrong. So this is never 100% accurate. And here in the paper, if you download that paper, you can see that we have taken quite mathematical approach to prove that intent classification can never be 100% accurate. Next one. Information retrieval. That's where the needle in the haystack problem is there. So I have like 100 information and I want to retrieve the right information. I can never be 100% sure that I have retrieved the right information out of the 100 information that I had to retrieve. So means, even if I have trained for the 100% data set, I cannot retrieve the right information with 100% accuracy. Next one, it's very, very interesting. Output generation, and that's why chain of thought and a lot of things like that are coming into the picture right now. And models like DeepSeek is getting popular because in output generation, again, follow my sentence properly, there is no a priori knowledge on exactly what is going to be generated, which is before I generate, I do not know what am I going to generate. I get to know what I'm going to generate only after I have generated. And that's the reality of AI, Gen AI language models. Okay, I do not know beforehand that exactly this is what I am going to say or I am going to generate. And that is a problem, because this is where I do not know what am I going to generate in between. There is a non-zero probability for me to generate things that are factually incorrect in between, right? Because if I do not know, I do not have control over it. I can give a lot of strategies to kind of pre-generate a lot of things, then generate in multiple stages. We can mitigate those strategies, but why those strategies are there to start with? Because there is absolutely no a priori knowledge. Point is, the lesser that we ask the language model to generate, the more is the probability of it hallucinating. Means, if I ask the answer in one word, it might hallucinate. But then if I ask it to show its own calculation, show its own reasoning, the probability of hallucination drastically goes down. So these all are strategies. We are talking probabilities. But deterministically, there is no way to make it 0%. That it will not generate something which is not right. Last one is post-generation fact-checking. I go to the first one, training. If we do not have a training data set which is complete, we also technically don't have a fact-checking database which is also complete. That's the final one. Also, whose generation has to be, fact-checking is also an LLM. Like, it has to be an LLM to do the fact-checking, right? Fact-checking will also have information retrieval problem. It also has the intent classification problem. It also has the training problem. And that's why there is a non-zero probability that even if the output generation says this is right and fact-checker says this is right, we have no way to say which right is the right one. So in the whole way, there is a non-zero probability for us to generate things which are factually incorrect, hallucination. I say hallucination is the feature. We do hallucinate. That's why we are creative. We do not know what we are going to do. That's why we are unpredictable, and that makes us human being. Let's not be very harsh on hallucination. Let's understand this is the structural issue of the language model. It's not issue, sorry. It's a structural feature of language model. And in that structural feature, the thing that we can do is, can we say a cardiologist will never make a mistake while doing a cardiac surgery? He or she might. A pilot may make a mistake while flying a plane. But it is sensible not to allow a cardiologist to fly the plane, or not to allow a pilot to do the cardiac surgery. That is just being sensible. That does not mean they don't individually make mistakes. So what we do in this real human case, we have verticalized approach to create verticalized things, which is like, I don't want a language model to write poems like Tagore and then explain like Einstein and then flirt with me at the end of the day. I don't need that. We need specialized language models. That's just more sensible. That's human being. That's us, right? So when we have specialized education, specialized qualification, the probability of that going wrong can be controlled to the extent of being acceptable. Things do go wrong. Let's understand that. There's nowhere in the earth wherein we can say things don't go wrong. So tomorrow, someone comes and tells you that my model does not hallucinate, at least you can reference this paper. It is mathematical. No one could actually mathematically reboot this paper. If you want, you can do that. But it is kind of foundation of mathematics we have used. So you can reference this paper. That it is impossible to have a language model which will not hallucinate. But the point is, can we have a sensible approach towards GenAI, which is to allow a pilot, after a thorough pilot training, to fly the plane, or allow a cardiac surgeon, after a thorough training on cardiac surgery, to actually go ahead and perform the surgery, and not allow both of them to interchange their role at wish. I will go a bit into the mathematical part. I have already said it without actually going to the mathematics. This is called Gödel's incompleteness theorem. It actually took down the whole mathematics per se. our understanding of mathematics that, if I add 1 plus 1 is equal to 2, and that was the proof that someone actually tried to do, not someone, best of the mathematicians at that time. So Principia Mathematica was about proving 1 plus 1 is equal to 2. Turned out we actually could not prove 1 plus 1 is equal to 2 because of Gödel's incompleteness theorem. I'm not getting into the mathematical rigor of it, but let's go to the statement. This statement is true and not provable. If this statement is true and not provable, then can I prove this statement? If I can, then this statement is false and provable. If I can't, then this statement is not provable, hence this statement is not true. Mathematics is not that consistent. What we were always taught about, 2 plus 2 is equal to 4 or 1 plus 1 is equal to 2. Okay, 1 plus 1 mostly is equal to 2 is the best answer that I can say, but I cannot definitively say that mathematics is complete. Same way, Gödel's incompleteness theorem is about that, incompleteness. And this, we have used the Gödel's incompleteness theorem to kind of get into the language model that they also are suffering from the same incompleteness, which is a part of the mathematical incompleteness. So there's nothing complete. Because there's nothing complete, there is a non-zero probability for anything to go wrong. Next one is halting problem. If you see, halting problem is, Turing's best work on computer science. So computer does not know when to stop or whether to stop or not. Change computer to language model, does not know when to stop, whether to stop, how to stop, because a priori there is absolutely no knowledge. Till the time it has actually stopped, it does not know where to stop. So we are back to square one. So we have taken these things. So again, not going deep into that. It was not a problem with this example of needle in the haystack actual this thing. So I asked ChatGPT that Bollywood movies released between 1990 and 1999, and these all are none of them are structural. This can be solved. So it had given like Munna Bhai MBBS, but that was after 1999. So and if you think about this way, it's a very easy SQL query, right? If I have to write the SQL query, it's just from Bollywood movies, from between this to that, and IMDb 8. I mean, your SQLs will never make it wrong. It's very easy to do that. But here, it did it wrong. Like, Dil wale dulhaniya le jayenge. I'm like, DDLG, really? Kuch hota hai? Who is the doctor? I don't know. Finally, I asked how about ek doctor ki maut? It can verify it. So, not that it did not have the information with it, just that it could not do those structured queries the way we are comfortable doing it. So, yes, I mean, these are all the places things hallucinate, but before, after the DeepSeek, deep thought models, like, few things are solvable, okay? Now, this is a structural hallucination. It can never, no LLM can never solve it, so you cannot do that. So, just follow this command. It's a structural hallucination. Create a random 5-word sequence. Exactly 5 words before the end of your answer, add exactly 5 more words left. So basically, for every 5 words, I'm adding 5 more words. Then that should add 10 more words. That should add 15 more words. So it has to start with infinitely more words left, infinite minus 5 more words left, infinite minus 10 more words left, like that it has to come. So it is a structural hallucination. No one can solve it. It's unsolvable, but somehow we did something with it. Okay. Now I will do a real we'll take our discussion to something much deeper. This is my last slide, but I'll take my discussion to much deeper. Do you guys have ChatGPT in your phone? Can you do me a favor? I'm going to give you a prompt that you're going to see on the next page. And before the prompt appears, I'm going to make a prediction. What are you going to see as a generation? Because this will give us a lot of understanding on how data impacts hallucination. And I have never talked about that. And so this is the right time for me to talk about it. So you're going to see this prompt, you're going to write this prompt on ChatGPT. I'm giving you the answer, and I'm not giving one prediction, I'm making two predictions. Both of them will be correct. The time that you will see is going to be 10, 10 or 150. Number one prediction. Number two prediction is the numbers on your dial are going to be wrong. Now you write this prompt. Generate an image of an analog clock with a display time of 628. Write it down. My predictions, I had made two predictions, not one. Prediction number one is it is going to generate 10, 10 or 150, and numbers in the dial shown are going to be wrong. Generate an image of an analog clock with a display time of 628. Anyone generated ChatGPT? We are talking about AGI, general intelligence. I know this is like, a kindergarten level question. Could you generate? Anyone? Yes, no? 10, 10, great. And can you confirm if the number in the dial is wrong, 1, 2, 3, 4 to 12, it could not do it properly? Could it? Could it not? Huh? What is the time that it is showing? 10, 10. 10, 10, 150. Same dial structure. And the numbers in the dial, they're all screwed up. At least once. Correct? Great. Why did it happen? Exactly. Most of the images have the time 10, 10. So it does not know how to. Now 10, 10 is this angle. 628 is very close niche. It's like two angles, and my query was you have to make it completely different. It just does not know how to do that because it was trained on such a massive amount of data set which is so biased towards 1010 that now if I ask 628 or 625, it just does not know how to do that. Point is, more data leads to this hallucination. It is not less data. More data of a particular type. So most of the times people ask me like, should I train this? Should I train this? As a CTO or the founder of the company, my choice is what not to train with. It is not the other way around what to train with. Because if I train with the same data set that my model already knows of, it is going to hallucinate more. Now, this gives us a question of the next round, which is, if we are able to solve it, I'll be scared either ways. You know what is the solution for this? Any guess? How can we solve this? ChatGPT could not. I'm pretty sure everyone in OpenAI, they know about this problem, but they are not able to solve it. How can we solve this problem? Sorry? Rephrasing the question, you can rephrase it in 100 ways. It is not going to generate. You scold ChatGPT right now. What are you doing? Have you done it correct? Even then it cannot. Point is, it has to then use a biased data set. It has to remove at their own convenience, make the data set more diverse by introducing a positive bias to correct a sentence. Now, because of hallucination, if we are allowing people to go for bias in the system, very soon we will ask uncomfortable question, whose bias? is the right bias. I can keep on giving examples. Because if we do not give bias, only go by numbers and mathematics, as a society, we may not agree with those ideas which are mathematically right. Language models can potentially tell things, and this is not me who is telling, so I'll be supporting it with data, potentially tell things which are misogynist, just that my data says so. Potentially say things which are racist because my data says so. Because as a society, we are misogynist, so the data that we create are in misogynist in nature. Now, if we train on that data, it will be 10-10. Now, if we have to fix it, we have to induce our own bias. It is like online fact checking. Whose fact is the correct fact? The person who has produced the data, or the person who says that I am the authority of checking the facts? The conundrum starts right there. Conundrum does not start with the fact of lack of data availability. Conundrum starts with the availability of repetitive data, and some engineer somewhere like us working over that data in the name of positive bias, and we just do not know where does it end, because positive bias is needed. So when this problem gets solved, please understand there will be some positive bias being induced on the data set. That should not make you comfortable, that should make you equally uncomfortable, because then now we have bias in the data that we know of. And that's the only way to solve it. I have 3 minutes on my counter and I'm open for a question. Thank you so much.